Welcome to the SAT Mathematics section. In this video, we're going to look at arithmetic. Once again, I'd just like to say that this is more of a crash course, and we're going to be browsing through some important concepts that come up very quickly over here. So I do recommend, if you are particularly unsure of a certain topic, that you do some in-depth learning in that topic and do some practice problems. This is just like a quick refresher and just clarifying some common misconceptions and talking about how we approach certain types of questions that come in your SAT, right? With that being said, the first thing I'm going to discuss is absolute values. So how these things work is these two bars signify that we're taking the absolute value of what is inside. No matter what the number inside is, it will return a positive value. It will return the positive version of that number. So a positive number will remain a positive number, but a negative number will be transformed to a positive number, right? If we have a negative sign outside these bars, it carries forward. Therefore, even though this -5 is becoming a 5 over here, this minus will once again turn it into -5, right? This minus sign. So that's kind of how absolute values work. So here's one question. I recommend you pause the video, try and solve it yourself, and do this for every question that will follow in this video, just to see if you know how to solve it, or even if you're confident that you do know how to solve it. Just as another practice problem, right? So how you're going to approach these is you're first going to deal with the absolute values in between the outer bars. So the absolute value of -10 is 10, and the absolute value of 15 is 15. This minus sign is outside, so nothing happens to it. So then we're left with this, the absolute value of 10 minus 15, which is the absolute value of -5, which is nothing but 5, right? Another thing that I think it's important that we cover over here is the idea of subtracting a negative number, right? So if I'm saying that I'm subtracting -4 from 3, it means there is a subtraction operation going place, which means there is another minus sign. These two minuses become a plus, and therefore when I'm subtracting -4 from 3, the result is 7, right? And the same applies to finding the difference where one number is negative. So if I'm saying define the difference between 10 and -3, how you approach it is, so difference is always larger number minus smallest number. So you would do 10 minus -3, the minus will become a plus, so 10 plus 3 is 30, and therefore the difference between 10 and -3 is 13, right? Something else you need to look at is the greatest common factor and the lowest common multiple. The greatest common factor is if you have two numbers x and y, it is the largest number which is a perfect divisor for both x and y. The lowest common multiple is the smallest number that is a multiple of both x and y. We find these using a method known as prime factorization. So how we do it is, if we have the two numbers 54 and 63, we draw this elongated kind of L. And we write 54, 63. We think of the smallest prime number that is a divisor for both of these. So 2 is only a divisor for 54, not of 63. So we move on to 3. 3 appears to be a divisor for both, so we continue. So we write 3 on the left. Then below the L, we write 54 divided by 3, 18, and 63 divided by 3, 21. Once again, we repeat the process. We find that the smallest common divisor here is 3. So once again, we draw another elongated L, and 18 divided by 3 is 6, and 21 divided by 3 is 7. At this point, we realize there are no common divisors, and therefore we stop the process. The HCF is the product of the values on the left. So it is 3 into 3 is 9. Therefore, 9 is the highest common factor of 54 and 63. The LCM is the product of all the numbers on the left plus the numbers that are at the bottom, multiplied by the product of these and the numbers at the bottom. So it becomes 3 into 3 into 6 into 7, which is 378, and that is the lowest common multiple for 54 and 63. Indices. Now this is something, if you're unfamiliar with, or if you're not in particularly solid ground with, I recommend that you practice a lot of questions that do involve indices, because this is something that does get almost all things get better with practice, right? But this is something that this is something where practice is perhaps the only way to get better in short periods of time. So there are a number of laws. A raised to the negative c is equal to 1 by a raised to the power c. What I'm saying is, if the question says 3 raised to the power minus 5, it is the same as 1 divided by 3 raised to the power 5. So the base just goes to the denominator of the unitary fraction and the exponent becomes positive. A raised to the power 1 is equal to a, which means anything raised to the power 1 is equal to the original thing. So 5 raised to the power 1 is 5, 25 raised to the power 1 is 25, right? Anything raised to the power 0 is 1. So 30 raised to the power 0 is 1, 2 raised to the power 0 is also 1. And then we come to the slightly more useful laws when it comes to indices. So a raised to the power c multiplied by a raised to the power d is equal to a raised to the power c plus d. So if you have a question that goes 3 raised to the power 2 into 3 raised to the power 3, it is the same as 3 raised to the power 2 plus 3, which is 3 raised to the power 5. A raised to the power c divided by a raised to the power d is equal to a raised to the power c minus d. So if a question that goes 3 raised to the power 2 divided by 3 raised to the power 3, it is equal to 3 raised to the power 2 minus 3, which is 3 raised to the power minus 1. Now from the previous slide, we know that is equal to 1 divided by 3 raised to the power 1, and therefore it is equal to 1 by 3. A raised to the power c raised to the power d is equal to a raised to the power cd. So 3 raised to the power 2 raised to the power 3 is equal to 3 raised to the power 6, because 2 into 3 is 6. A raised to the power c multiplied by b raised to the power c is equal to ab raised to the power c. So 3 raised to the power 5 into 2 raised to the power 5 is equal to 6 raised to the power 5, because 3 into 2 is 6. Similarly, a raised to the power c divided by b raised to the power c is equal to a divided by b raised to the power c. So 5 raised to the power 8 divided by 3 raised to the power 8 is equal to 5 by 3, that whole fraction raised to the power 8. Now we'll look at some questions. Pause the video as the question statement comes up. So often you'll have something like this where they'll give you an expression and they'll ask you to express one of the variables in terms of the rest. So your first step, how you want to do it is you want to first reduce both sides to one exponent, right? One exponent. So we know from the the laws regarding indices that this is just equal to 2 raised to the power ab, and this is just the final exponent over here is the addition of is what happens when you add c plus c and d. So therefore we end up with this, and now given that both sides have only one term and both sides have the same base, which is 2, in order for the LHS, the left hand side, to be equal to the RHS, the right hand side, the exponents have to be equal. Therefore we can come up with this. Now it's just a matter of eliminating b from the subject, so we divide both sides by b and therefore we get the answer, right? This is a rather simple question. I've just included it because I think it's important. So here, this is a simple case of applying index laws. The bases are the same, and therefore it is just the difference between. It is just about finding the difference between the powers. So we end up with this 4 raised to the power 3 minus 3, and therefore the answer is 4 raised to the power 6. Now, since we have discussed a lot of operations, I think I'm just going to bring up that any question that has multiple things happening, so that has brackets, maybe indices, it also has multiplication and maybe subtraction. There is a particular order in which you solve the question. You'll always do what's in the brackets first. You will always do anything involving indices next. You will always do division after that, then multiplication, then addition, and then subtraction. At this point, I also want you to realize that when you add or subtract two odd numbers, it is even. When you add or subtract two even numbers, it is also even. But when you add one odd number with one even number or subtract that way, it is odd. This holds true for both addition and subtraction, because addition and subtraction are practically the same operations. Like, what I mean is 5 minus 2 is the same as adding negative 2 to 5. So they're, because of how similar these operations are, they do generally hold true. They do hold true for both addition and subtraction. Similarly, these three, they hold true for division as well, so long as there is no remainder and the quotient is a whole number. So any multiplication or division operations between two even numbers will result in an even number. Any multiplication or division operations between two odd numbers will always result in an odd number. If one number is even and while the other is odd, the result is going to be an even number if you're doing a multiplication/division operation. These are some values I do recommend that you guys keep in the back of your head. So pi is 3.14 approximately, is 2.71, root 2 is 1.414, root 3 is about 1.73. And if you have to approximate the root of any obscure number such as 89, right? A nifty tip over here is try and find two numbers that try and find the two square numbers in between which your number lies. So if I want to approximate the value of root 5, 5 lies between 4 and 9. And therefore the root of 5 needs to be greater than root of 4, but must be smaller than the root of 9. The root of 4 is 2, the root of 9 is 3, and therefore root of 5 lies between 2 and 3. Similarly, 39 lies between 36 and 49. Therefore, root of 39 lies between root of 36 and root of 49. Therefore, root of 39 lies between 6 and 7. This is quite a useful tip that might be useful somewhere. And there are these there's this type of question that comes up in your SAT that is basically arithmetic questions that I do think I need to cover how you approach these questions. So they will generally look something like this. So you'll have a condition. So here they're specifying there is two numbers x and y that lie between 0 and 1, where y is greater than x, right? And then they have three statements. So there is a lame, not really the best way, but it works for most of the cases because there is no negative marking. You have nothing to lose if you can't think about the question intuitively. This is what you should do, and it will maximize your chances of getting the question correct. You take two values x and y that fit these conditions. So both of these are between, we take 0.2 as 0.5. It does not need to be this way. It can be any two numbers that are between 0 and 1, but y needs to be the greater value, right? So for this question, I've taken x as 0.2 and y as a greater value, 0.5. Both of them still lying between 0 and 1. So for the first statement, it says x minus y is negative. So I do x minus y with my numbers I've selected, right? So 0.2 minus 0.5 is negative 0.3. It is negative, so 1 is correct. 1 by xy needs to be greater than 1. Now xy is equal to 0.1, right? 0.2 into 0.5 is 0.1. And 1 by xy is therefore equal to 10, which is greater than 1. And therefore the second statement also holds true. The third statement, which is 1 by x minus 1 by y, is negative. 1 by x is 5, 1 by y is 2. 5 minus 2 is 3. This is positive, therefore the third statement does not hold true, and therefore we have actually already solved the question. We know that 1 and 2 are correct, 3 is not correct. The better way to do it is to intuitively think about it though, right? Now x is smaller than y, right? When you subtract a larger number from a smaller number, of course you're going to get a negative number, right? So without actually doing any substitution or forgetting values, you should know that 1 is always going to be true. The second question is where things get tricky. But once again, both of these are decimal numbers that are between 0 and 1, right? When you multiply two decimal numbers that are between 0 and 1, you still end up with a decimal number. And the decimal number between 0 and 1 is of course smaller than 1. Therefore the product xy will fit more than one time in 1, and therefore your answer has to always be greater than 1. The only place where this expression would not be true is if xy is 1 or is a number greater than 1, right? And or is a negative number, but both x and y are positive, so there is no question of that. So the only places where this would not be true is if xy is 1 or greater than 1, right? Now x and y cannot be equal to 1 over here, because and x and y can never be greater than 1 here, because there is no whole number in the first place. Both of them are decimal numbers. Both of them are fractions smaller than 1, which means that it will always be greater than 1, right? The entire expression. I realized that might have been really confusing, and why is it email notification here? But right, so I realized that might be really confusing, so just pause the video, try and think about what I've just said, and then leave something in the comments if you are still confused. Now 1 by x minus 1 by y, we know x is smaller than y, therefore the number x will fit more times in 1 than y, therefore the expression 1 by x will always be larger than 1 by y, and therefore it has to be positive. In simpler words, if I have if x and y are whole numbers and this set 4 instead, right? I could take x and x was something small like 1 and y was something slightly larger like 2. 1 would fit 4 times in 4, but y would fit only 2 times in 4, right? Therefore, therefore 4 minus 2 would always be positive. Similarly, x is a smaller number here, therefore it will fit more times in 1, and 1 by x is basically just how many times x fits into 1, and 1 by y is nothing but how many times y fits into 1. Since y is a larger number, it will fit fewer times in 1 than x does, and therefore the expression 1 by x will always be larger than 1 by y, and therefore the answer will always be positive. And once again, if you haven't understood that, you always have the other method to do it, which is substituting numbers and checking it out. But I do recommend, if there's something that's particularly confusing you particularly, leave a comment about it so I can get back to you, right? And so another similar question I do want to cover is, given the premises that x and y are prime numbers that are greater than 2, where x is the larger number, which of the following is true, right? So now, once again, there's two ways to approach the first statement. X and x minus y is odd, right? So you can take two prime numbers that are greater than 2. So we can take 7 and 3, and 7 minus 3 is 4. 4 is an even number, so that's not true. The better way, how you should be actually thinking, is that 2 is the only even prime number. Therefore, x and y have to be odd. Any additive or any subtraction operation between two odd numbers is always going to result in an even number, and therefore it has to be even. Therefore, 1 is never true. The second statement, which is xy is odd, you can once again multiply and you will see it turns out to be true. But how you should be thinking is x and y have to be odd, since 2 is the only even prime number, and when you multiply any two odd numbers, you always get an odd answer, and therefore it has to be true between any things. There are some algebraic proofs that will allow you to see why when you multiply two odd numbers the result is always odd, but so I do recommend you check those out. I'm not covering it in specific, but I do recommend you check those out if you haven't seen them before. And the third statement is slightly trickier. So once again, you have the basic method of taking those two numbers. 7 squared is 49, 3 squared is 9. It results in 58, so that is not true. But how you should be thinking is, we already know that x and y have to be odd, right? What is x squared? X squared is nothing but x into x. Given that x is odd, it means that we're doing x and y are odd. That means we're not doing nothing but multiplying an odd number times an odd number to obtain x squared, and another odd number times that same odd number to obtain y squared, right? What does that mean? It means that both x and y is odd. Both x squared and y squared is odd, because they're nothing but the product of one odd number multiplied by itself, which is... So given that both x squared and y squared is odd, we do know that any additive or subtractive operation between two odd numbers is even, and therefore 3 has to be false, right? And that is the better way of doing it, because it actually involves logical comparisons, and it actually involves logical steps, and actually involves understanding of why with each statement is true, but this method does work perfectly well if you aren't able to make sense of a particular question. So don't try to reason it out in the test if you cannot. Try and answer all those questions in the given time. But when you're practicing tests at home, try and make sure that you're reasoning it out, so that will improve the speed at which you can reason it out in your actual SAT. And yeah, with that, in the next video we're looking at fractions, decimals, percentage, ratio, proportion, that whole thing. And with that, thank you guys, have a great day. Thank you.